So, we've got this up our sleeve now, right? I want to keep digging into this. I'm going to introduce a bit more notation for you. This is a very long way to write this out, simply because there are so many terms there. You can see mathematicians are always after patterns. Every term in this series follows exactly the same pattern. It's incredibly predictable, right? In fact, you can say for any given term, its format, right, the way it's laid out, looks like this. The rth term, okay? Which term is the rth term? It's going to be NCR, and then the power of x is going to match that r number down the bottom, right? And that'll be the rth term, which does mean that this is the 0th term. Okay, so watch out for that, but I think it's much more helpful to understand that as a 0th term than the first term. Okay. Now, if that's what each term individually is, then this whole series is just the sum of all of these guys, right? So I'm going to write that like this, right? 1 plus x to the n, that's the whole thing. That's equal to, now I want you to draw a big Greek letter for me. It looks like this. This is called sigma. It's a great letter. It's one of my favorites. It just looks cool when you draw it. Okay? Sigma. Let me make you a quick warning. Okay? That's what sigma should look like. It's a capital sigma, by the way. Lowercase sigma looks completely different. A lot of people draw their sigma like this. And my heart dies a little time every time someone draws their sigma like that. Okay? Please don't draw your sigma like that in this classroom. I will throw a sharp implement at you. Will I deduct marks off you? Probably not. But just draw it properly, okay? That's what sigma looks like, not like that. Okay, now this sigma notation, it's sigma for sum, S for sum. Okay, so I'm adding up all of these terms, right? I'm adding up terms that all look like this, right? So I'm going to start. Whoops, that's not right. I want R. I want to start with the first term has an R value of 0, right? And it's the very first term. What value did the last R term have? I start at 0, there, and then I end at n, right? Okay, that's my last value there for R. R is the number that's changing all the way through. Okay, so I'm adding up all of these terms, right? So this is a way for me to write this, but I'm kind of like, there's so much repetition, right? They all look the same. They all look exactly like this. So this is my shortcut way of saying it. I would read this as 1 plus x to the n is equal to the sum from 0 to n of NCR x to the r. I'll say that again. Okay, 1 plus x to the n is equal to the sum from 0 to n, so they're kind of like a starting point and an ending point, of this thing. And we call this, another name for it is, this is the general term. It's called general because it's generally what they're all equal to. Okay? That's the general term. Okay, now, being that we've got all this fancy new notation, and we also have Pascal's triangle on the board, okay, I'm going to use this notation to express some of the properties that we've already noticed in Pascal's triangle. And this will start to dig at some of the why questions I asked you yesterday and left you, sitting with. I'll answer one of them today, but only one, okay? See how we go. So, what are some properties that you see? Okay, I can see 3 very simple basic properties. The first property I see is that all of these numbers on the outside, right, all on the edges, they're all 1. You don't need any thinking to notice that they're all 1. So how would I write that down? How would I articulate that? Yeah.
First and last coefficient of each of the terms is 1.
Okay, all right. Let me go with that idea. We started with first and last, and we said coefficients, right? So these guys are our coefficients, yeah? So how do I say first coefficient and last coefficient? Because I have language for this now that I can use to describe this. Doris?
NC0 and NCN are always 1.
Good. Okay, there you go. My notation allows me to just write it, not just say, where I put it. Rather than say, this fret that's about a third the way up and that other fret that's about half the way down, kinda-ish, a little bit in, I actually have precise language for this, okay? So I can say, here's number 1, right? I'll put this right here in the middle here. This is property number 1, okay, out of Pascal's triangle, that NC0 and NCN, they're both and always equal to 1, no matter what n you throw in there. Okay, good. So you've got the 1 idea. Another basic property that we've already referred to this morning is that the whole thing is symmetrical. Once you've got one half of Pascal's triangle, you've got the other half, okay? So how could I articulate that? This is a bit trickier, okay? For instance, let's have a look here. We looked at these two, right? So we've got 11C5 and we've got 11C6. And they're equal. You can see it on the board, right? But they're not the only ones that are equal. Let's pick out another pair. Say 11C2 should be equal to 11C9, right? 11C9? And you could pick out another pair. For instance, without writing it down, 11C3 is going to be equal to 11C8. I have some examples, right? You got this one, you got this one. What's the pattern? Yeah, good. These subscripts, the R, which term you're going along, these guys should always add up to this guy, right? These guys to this guy, these guys to that guy. Can you see it? Okay. So for instance, if I were to say, all right, for any term along there, right, it's going to be equal to its opposite one in the same row. So it's clearly going to be in the nth row. What would this number down here be? Yeah, Brendan. N minus R. Can you see it? Let me replace them for you, right? This 8 is really 11 minus 3. That's what it really is, okay? And this 9 is really 11 minus 2, right? Another way of thinking about this is, what's 2, right? I'm going to give you a really weird way of saying 2. 2 is 0 plus 2, right? So you start at this end and you go that way, 2. And then this is 11 minus 2. You start at this end and you go 2, right? So that's what this is referring to. They're not just numbers. This is symmetry in here. Okay? One last property, and we're going to quickly prove it, okay? It's one of the properties that I gave you yesterday, and you were like, what? Okay? We said that this row, it adds up to 1, and this row adds up to 2, 4, 8, 16, 32, and so on. Okay, so this is kind of like the sum property of every row. So, before we prove it, how do we state it? How do we state it? I'm probably going to need more room that's in my box. Okay, so 2 to the power of n, right? That's the sum of, it's the sum of all of these coefficients, isn't it? Right? Not the x's, forget about those guys, it's just the numbers, right? So I'm going to write that as 2 to the n is the sum from r equals 0 all the way up to n of just the coefficients.